fellow scientists! My name is Valerie.
And I'm Sophia.
Today, we thought we would show you guys an experiment and teach you about the scientific method along the way. So, the experiment we will be conducting is called the apple browning experiment.
In this experiment, we will see which liquid will prevent the apple from undergoing the oxidation process the best. Now, you may not know what the oxidation process is, so I'm going to explain it. You know when you cut into an apple and leave it out for a while and it starts to turn brown? Well, this is what the oxidation process looks like.
Now, let's begin with the scientific method. The first step of the scientific method is to ask a question.
The question we will be asking is, which liquid will prevent the apple from browning the best?
This experiment will take place overnight, which is about 7 to 12 hours. The second step of the scientific method is to conduct research. This is a step where you would do some research to further understand the components or each component of your experiment and clarify any confusion you may have.
We've already done this step off camera and became knowledgeable about this experiment.
The third step to the scientific method is to create or develop a hypothesis. A hypothesis is similar to an educated guess. It is a proposed explanation made on the basis of limited evidence. It serves as a starting point for further investigation.
Also, Valerie, don't forget that when developing your hypothesis, it is important to make sure that it is structured correctly. What I mean by this is to put it in what I like to call an if, then, because statement. So, what's your hypothesis?
My hypothesis is that if I put lemon juice on the apple slices, then the lemon juice will keep the apple from browning the best because of the citric acid lemons obtain, which will delay the oxidation process from occurring. Do you agree?
Yes, that's what I hypothesized as well.
The fourth step of the scientific method is to do the experiment. So, we will be conducting the experiment by first off identifying the variables. An independent variable is a variable in the experiment that will change. It is the variable being tested. There is always going to be only one independent variable. In this case, it is the different types of liquids being tested. Then we have a dependent variable, which is a variable that changes in response to the independent variable.
This would be the amount of browning the apple slices will have after the time elapsed. Lastly, we have the controlled variable, which is a variable in the experiment that does not receive the independent variable being tested in order to compare its results with those who received the independent variable. In other words, the controlled variable is the apple slice with nothing on it in this experiment.
So after you identify your variables, you're going to begin the experiment. So to begin, you are going to measure 2.5 tablespoons of each of the liquids being tested. Those liquids are lemon juice, water, milk, and vinegar. And then you're going to have one bowl with nothing, so no liquid that's being tested because, as I mentioned earlier, this is your control variable. Another thing you're going to need for this experiment is an apple. You're going to cut the apple into 6 equal slices and then place 5 of those individual slices into the bowls for testing. And then that extra slice, you can just put it to the side for now. You're also going to want to label each of the bowls so you know which liquid is being tested in which bowl because, for example, water and vinegar, they can be very confusing since they're both clear if you do not label them. So I'm going to go ahead and cut this apple off camera and put them into the bowls, and then I'll be right back.
Alright, so I'm back and I finished cutting the pieces. As you can see, I have my 5 pieces equal, and then I have the 6th one here by the side. And so now what we're going to do is we're going to pour in the liquids. So, got lemon, water, milk, and vinegar. And then our last one with nothing. So now we're going to leave these soaking overnight and make sure to write down any observations you may see as the time passes, like if you walk by it and you notice that one of these is browning faster. Also, don't forget to record your final data at the end. And you want to replicate this experiment 2 to 3 more times to gather more data. And Now we're going to wait overnight. I'll see you then.
After identifying your variables, begin the experiment by cutting your apple into 5 slices and putting each of them into an individual bowl. Also, don't forget to have your control group. So what the control group is going to be is the apple slice with nothing on it, just in a separate bowl by itself. And I use a silver bowl so I could differentiate them from the rest of the bowls. Now what you're going to do is you're going to take 2.5 tablespoons of each individual liquid being tested, and you are going to pour each of them into a separate bowl. Also, make sure to label which liquid you put into each bowl so it's easier to record your observations later in the process. Now you're going to leave these apple slices overnight, and as the time passes, try to record any observations and record your data along the way.
The phenomenon that is required to happen is for the apple slices soaked in lemon juice to not brown as much or at all compared to the other apple slices in the experiment. The lemon juice liquid prevents browning by how it is full of citric acid and ascorbic acid, also known as vitamin C.
These acids form a coating around the oxygen atoms in the apple. This prevents it from browning until the acids run out and the oxidation process begins.
The 5th step of the scientific method is to analyze your data. In this step, I will go over the data that I previously recorded while doing the experiment, and Sophia will go over her data.
In order to do this, you should look at your data and see if you can locate any patterns and determine what apple slice browned the least, therefore telling you which liquid prevents the apple from browning the best.
My data analysis for trial 1 is that, as you can see by the bowl with nothing in it on the far left, this apple slice browned a bit, but not too much. Then the bowl after that, we have the bowl that has the liquid component of milk. This apple slice prevented the browning process the second best. However, there's another liquid that was able to prevent the process even better. After that, we have the bowl with the vinegar in it. This apple slice actually browned the most. The vinegar seemed to speed up the process. After that, we have the bowl with the water. This apple slice browned a fairly similar amount to the apple slice with nothing on it. Lastly, we have the apple slice with lemon juice in it all the way on the far right. This apple slice barely browned at all. It was intact. It seemed as if it didn't brown at all. Data analysis for trial 2 is that, as you can see by the cup on the far left, which is the apple slice with nothing on it, it browned a little bit more than trial 1, but it still was not a lot of browning. After that, we have the bowl with the apple slice soaked in milk. This apple slice browned a decent amount, but as stated by the other one, this was actually one of the better liquids that was able to prevent the browning. But, however, there's another liquid that prevented the browning even more. After that, we have the cup that had vinegar in it in the center. This cup had the apple slice browning the most. It seemed as if the vinegar sped up the process as seen in trial 1. After that, we have the cup with lemon juice in it. As seen in trial 1 as well, this apple slice browned the least. It remained almost intact. And lastly, all the way on the far right, we have the cup with water in it. And this apple slice browned a bit more than in trial 1, meaning it was darker than the bowl with nothing in it.
Okay, so here's my data analysis. This is my trial 1. So all the way to the left, we have our lemon juice, and you can see that it barely turned brown from the beginning to the result right now.
And then to the right of the lemon juice, we have the milk, and it turned a little brown. And then we have to the right of the milk, the water, and it turned a little more brown than the milk and the lemon juice. And then we have the vinegar, which so far turned the most brown out of all of them. As you can see, it's really dark. And then to the right of the vinegar, we have our control group, which again had no liquid on it. And you can see the vinegar turned more brown than the control group. So the water in the control group turned around the same color of brown. So overall in trial 1, the lemon juice was the one that browned the least, and the vinegar was the apple slice that browned the most. Now for trial 2. So all the way to the left, we have the apple slice with the vinegar on it, and you can see it browned a lot, just like the first trial. And then to the right of the vinegar, we have the milk, which it actually did pretty good. It didn't brown as much as it did in the first trial, so I think it did better in this trial. Now we have to the right of the milk, we have the water, and this one browned a good amount. And then to the right of the water, we have the lemon juice, and this one didn't brown at all, just like it did not brown in the first trial. And then we have our control group, which browned a little bit. I would say in the last trial, it browned more than it did in the second trial. And also in this trial, the water browned more than the control group, which was different in the first trial, which had the control group brown a little more than the water, but they were still the same amount, a little bit.
The sixth and final step of the scientific method is to form a conclusion.
In this step, you will support your experiment explanation.
Also, determine whether your data supports your hypothesis.
If not, write down what could have caused those results.
So my conclusion is that overall, the liquid that was able to prevent and slow down the apple slice from browning was the lemon juice. Again, as I stated before, this is due to the acids and vitamin C's that are inside the lemon juice that coat the apple slice, thus preventing it from browning. My data did support my hypothesis because, as my hypothesis stated, I believed that the lemon juice would prevent the apple slice from browning a little, or at all in this case, because the apple slice remained intact. It didn't brown at all. And my data did support this.
So now I'm going to reinforce my experiment explanation. So, overall, the liquid that was able to prevent the apple from browning the best was the lemon juice. Again, this is because the acids and vitamin C that were inside of the apple and formed a coating in the apple was able to slow down the oxidation process from happening. Now, my data does support my hypothesis because, as I previously said, my hypothesis said that the lemon juice was going to prevent the apple from browning the best, and as shown in my results from the experiment, they supported that the apple that had the lemon juice on it pretty much did not brown, and it browned very little, but pretty much it was the same as it was when I first placed the apple in the container at the beginning of the experiment. So overall, my hypothesis did support my experiment results.
Hello class. So right now we are going to be going over the apple browning experiment that we just watched. And we have our two scientists, Valerie and Sophia, here, and they're going to go over their data. So if you wouldn't mind, Valerie, could you tell us what you observed in your experiment?
Yes. So in my experiment, when I was conducting it, I noticed that the vinegar actually was browning the apple faster and speeding up the process compared to the lemon juice, which kept the apple intact. It didn't even brown, which was very surprising.
I see.
Another observation I noticed that was weird was that the apple, our control variable with nothing on it, and the apple that was placed in water looked almost exactly similar in color.
Interesting.
Yeah.
That's interesting. Okay. What about you, Sophia? Let's go look at your stuff. What did you observe?
Okay, so my experiment was almost the same as Valerie's. So my vinegar in both of my trials, it was the one that browned the fastest. And then my lemon juice didn't brown at all. It was like the same color as it was before. And some observations that I made were that in the lemon juice, the outside of the apple, it like changed the color of the water to like pink. So I thought that was like kind of cool. And then, let's see, my water and my control variable, they browned around the same amount. So like in trial 1 and trial 2, those are the two ones that differed, but the rest of the liquids, they were pretty much the same in both trials.
I see. And you said that the water, it differed. What do you think could be like? What do you think could have happened in one of your trials that made the water differ from like most brown to least like to the toxic browning? I guess.
Maybe in one of the trials, maybe the water evaporated.
Okay, that could be it. And Valerie, I think you also had something like that, like the water. Like you said here in your first trial, the third most. In the first trial, it was the third most, and then in the second trial, it was like the second most brown. Why do you think that could have been?
I think it could have been maybe the temperature my house was set, because since I didn't conduct them at the same time, because you're supposed to keep a couple minutes or something, it could have been maybe a temperature difference in my house.
Okay. Well, I see that at least both of your results that came out, like lemon juice was the least brown for both of them. So I think that's really good that even though like you guys conducted it at different times, your outcome was pretty much similar, only with that the water being kind of like changing depending on like the temperature or the time. So that was really good. I don't know if you want to add anything or like anything interesting you guys both saw from like your different data, anything at all. You can say it.
I'm good. This was a fun experiment. That's all I gotta say.
Well, that's perfect. Thank you for coming here and just discussing your information and everything. It was really helpful. Thank you.